Okay, so good morning, everyone. So today is our last meeting for our uh, histopathology online classes for this summer. Okay, so so this will be our last meeting, and I have already uploaded the last stream for the histopath discussions. Okay, so today we're going to start with sectioning and or microtomy. So sectioning is also known as cutting or microtomy from the word microtome. For it is a device that will made possible our sectioning. Okay, so the word comes from micros, which means small, and temnian, which means to cut. So the process by which a processed tissue is cut into a uniformly thin slices to facilitate studies under the microscope. So those thin slices of sections, those thin slices of tissues are known as sections, sa histopath. So routinely, our histologic procedure, yung size niya when it's being cut or section is 4 to 5 micra. If we're going to use rotary microtome with a biconcave knife, since yun yung pinaka-routine. For frozen section, it is 10 to 15 micra because the tissue, as we all know, for frozen sections are unfixed. Okay? For electron microscopy, it is 0 to 0.5 micra for electron microscopy. For electron microscopy, we are using ultra thin microtome, okay, for sectioning. Okay. In history class, the earliest form of microtomy was a freehand sectioning of a fresh or tissue or fixed materials using sharp razor. So the section produced could, with practice, be quite thin and translucent. Okay. So ito siya. Ito yung freehand microtome that was used before by our scientists for sectioning our tissues. So we have already discussed the types of microtome before during the start, but we will go to do it here again uh, to know the advantages of the different types of microtome. So first, we have the racking microtome. The racking microtome was developed by Paul Trefol in 1881. So it's also known as the Cambridge racking microtome. So this is the simplest type. Okay, but the disadvantage of using this type of microtome class is difficult in orienting the block. Okay, so nagiging movable yung block if we are going to use a racking microtome. Next, we have the rotary microtome or the minute microtome invented by Minot in 1885. So this is the most common type used today, especially for paraffin embedded tissues. Okay, so another types of microtome is the sliding microtome. So it's the most dangerous since the knife is exposed. So it is invented by Adams, and we have two types of sliding microtome. We have the base ledge and the standard sliding microtome. So what are the differences of the two types of sliding microtome? So the base ledge, the block holder is moving, okay, for base ledge, and the knife is stationary. For sliding microtome, the block is stationary and the knife is the one moving. Okay. Okay. So we have also rotary racking microtome. So later on, we're going to discuss it in a separate discussion since it is the most common or the routinely used microtomes. Okay. So vibratome used for unfixed, unfrozen, and specimen sections for enzyme demonstration. But the disadvantage of using this type of microtome class is liable to disintegrate our tissue since those tissues are unfixed and unfrozen. So easy to disintegrate, okay? And then the ultra thin microtome. So this microtome is specifically made for our electron microscopy, okay? So before, we have different types of uh, false uh, assumptions about different types of cells because of cutting different tissues thickly. Okay, on the invention of ultra thin microtome, okay, they already banish those types or those theories. Okay, so ultra thin microtome uses diamond knives or broken plate glass. So the specimen is small, fixed in osmium tetroxide, and embedded in plastic. And then we have the freezing microtome. Freezing microtome class was invented by Quiquet in 1848. So the clearance angle is 0 to 15. The bevel is 27 to 32 degrees. So bevel angle will be discussed later on. For routine work, a 76 by 25 millimeter slides that are 1 to 1.2 millimeter thick are usually preferred because they do not break easily. So since it is a frozen microtome, okay, they're using carbon dioxide for freezing. Okay, so after freezing, the tissue is exposed to a 45 to 50 degrees Celsius water bath. Okay, approximately 6 to 10 degrees Celsius higher than the melting point of the wax. Okay. Another one is the saw microtome. Okay, so this will cut sections that are very hard. Okay, so these are such specimens are undecalcified bones, okay, glass or ceramics. Okay, the samples commonly embedded in resins are moved extremely slowly against the diamond-coated saw, rotating at an approximately 600 RPM. So sections of 20 micrometer or greater are possible providing the saw blades is in a perfect condition. So very thin sections are not possible because nga, our saw microtomes uh, are designed to sections very hard samples. Okay? Yung mga undecalcified bones. So thin sections are not possible. So how to care for our microtomes? Okay. So after sectioning, all accumulated paraffin and small pieces of tissue must be brushed away with a soft brush. All parts must be wiped with xylene or xylol. So movable portion should be oiled thoroughly to prevent rusting, and microtome must always be covered uh, when not in use. So ito yung mga care of our microtome. So now let's talk about our microtome knives. So basically, we have three types of microtome knives. Okay, we have the plain concave knife. So the one side of the knife is flat, while the other is concave. For the less concave sides of the knife, it is used for the celloidine embedded tissues, while the concave part is for the paraffin section. Okay, used for our base ledge, rotary, and racking microtomes. Okay, biconcave knives. So both sides are concave. Recommended for cutting paraffin embedded sections on a rotary microtome. And our plain wedge, usually both sides straight recommended for frozen sections. So yung the one that we are using sa ating laboratory class is plain wedge knife for our rotary microtome. Okay? So extremely hard and tough specimens embedded in paraffin blocks using a base ledge type or sliding microtome. Okay. Next, this is the bevel angle. So since we have different types of knife with different types of pointed portion, the bevel angle is an angle formed between the cutting edges of all knives. So normally about 27 degrees to 32 degrees. A good cutting edge must be able to cut good sections from paraffin wax blocks about 2 to 3 micron thick. So the perfect and optimum cutting angle is obtained when the wedge knife are inclined at an angle of about 15 degrees Celsius. Okay. Ito yung bevel angle. So all types of knives meron silang bevel angle. So Usually, class, this bevel angle deteriorates or changes as the knife age. Okay? Age. So, nag-change siya. Kaya later on, we'll discuss about honing and strooping in order to maintain this type of bevel angle. Okay? Now, honing class, as we use our knives daily, so nagkaroon ng changes sa formation or sa edges ng knife. So nagkaroon siya, nagiging coarse yung edges. So honing is the removal of gross nicks on the end of the knife edge. So yung coarse honing. To remove blemishes and grinding the cutting edge of knife on stone to acquire an even edge. So ito yung uh, gagawin mo ulit na uh, matalim yung knife. So hard sharpening removes nicks and irregularities on the knife edge. So we have three types of hones, okay, used for honing our knife. So first we have the Belgium yellow. Ito siya. Belgium yellow are used for manual sharpening and gives the best result. Next we have the Arkansas. So more polishing effects than Belgian yellow. And then we have the fine carborundum. So much coarser than the first two used for badly nicked knives. Okay. So how do we perform honing? Okay. So we have this movement, the heel to toe. So heel is the handle of the knife and drawn obliquely towards the operator on the stone until the toe, okay, or the head portion is reached. So usually we do 10 to 20 strokes to give an optimum honing performance for these knives. So ito siya. Ayan. It's like a honing our knives sa bahay. Okay? It's just that we use special types of hones for these types of knives. Okay? Heel to toe. Mauuna sa handle and then going to the edge of the knife. Okay? So usually 10 to 20 strokes. Next, ito, honing. Ayan. Okay? Next is stropping. Stropping is the removal of burr formed during honing and the cutting edge of the knife is polished. So after honing class, meron siya mga parang dust made out of the burr formed during honing. So kakaroon ng mga dusty appearance yung ating knife. So to remove that, we're going to strop or perform stropping. Stropping is also known as polishing. Okay? So what do we use? Okay, we use paddle strap. Okay, paddle strap is made up of best quality horse leather firmly attached to a solid back to prevent sagging is preferred. Okay, if you have ever seen those mga barbershop class, so in order, di ba, they usually clean or their blades using leather. Okay, so that's stropping. Okay, so stropping is the opposite of honing in the position. Okay, so it is toe to heel direction, but it's usually 40 to 120 strokes. Okay, yeah. So the technique, the knife is laid on the near end of the strap with cutting edge towards the operator. Okay, so the knife held with a forefinger and thumb, and the action is exact opposite to that of honing. Okay, so ano siya? Toe to heel. Honing, heel to toe. Okay, I think at the end, okay. For disposable knives, we have two types. Okay, first we have these two disposable knives class are usually used for our electron microscopy. Okay, first we have the glass knives used for trimming and semi-thin sectioning tissue blocks for electron microscopy. Okay, ito yun, mga glass knives. So these are 40 by 2.5 centimeter plate glass strips. Okay, and another one, the most expensive, we have the diamond knives used to cut any type of resin blocks for electron microscopy. So basically, these are used for ultra-thin microtomes. So diamond knives are brittle and expensive. But It is the most durable if it is being used for most hardened, hard na specimen for electron microscopy. Okay? Since resin yung kanyang embedding medium. Okay? So I think it's the last slide for sectioning. Next, we have the rotary microtome. Okay. Okay, class. So rotary microtome is the most common or the routinely used microtome in the histopath laboratory. So ito yung meron tayo sa ating lab. So we have three types of microtome or the rotary microtome. We have the manual, semi-automated, and the fully automated rotary microtome. So this is the manual. This is the one that we have in our histopath lab. Okay, so this is completely manipulated by the operator. Okay, this is the semi-automated rotary microtome. This microtome we have it in SPMC. Okay, we have the semi-automated rotary microtome, one motor to advance either the fine or the coarse hand wheel. So yung one hand wheel, yung one wheel of this microtome class is operated by an operator, while the other one is move on its own. So semi-automated siya. Okay? And then we have the fully automated rotary microtome. So two motors that drive both fine and the coarse advanced hand wheel. Okay. So wala nang gagawin ang operator. Pipindot na lang siya, assign the type or the thickness of the sections, and then the microtome will section for him or her. Okay, so this is the fully automated rotary microtome. Okay, we do not have this type of microtome in our mga affiliated hospitals yet. Okay, so the advantages of using rotary microtome, so the ability to cut 2 to 3 millimeter sections, heavier so more stable, large and heavier knife, use less vibration when cutting hard tissues. Okay, the cutting angle of the knife is adjustable since you can use the three types of knives using rotary microtome. Okay, adjustable siya. Easy adaptation to all types of tissues. Can cut celloidine embedded sections by using a special holder to set the knife obliquely, and ideal for cutting serial sections such as large number of sections from each block. So those are the advantages of using a rotary microtome. Okay. Now let's discuss the parts of rotary microtome. So I know this is an assignment of yours. So I know you are familiar with this. Okay. So first we have the knife holder. Okay. A part that anchors the knife holder to the microtome stage. Ito yan. Diba? So the knife holder base can be moved. Ito siya. Knife holder base. Okay? Dito nilalagay yung knife holder. Okay? So the knife holder base can be moved towards or away from the block. So, gumagalaw ito siya, class. Forward and backward. So, must be stationary and locked during during microtomy or sectioning. So, nasa iyo yun kung gaano makalapit. Kasi kung malayo siya, class, medyo matagal yung pag-iikot mo ng hand wheel para lumapit yung section. So yung iba, ina-assign nila yung knife holder base medyo malapit na konti para less na lang yung ikot ng handle. Okay? Next, we have the knife holder. So this part is comprised of several components, including the blade clamp that holds the blade, the knife tilt, ito yon, for adjusting the knife angle, and the face plate that guides the ribbons away from the blades and towards the operator. Okay, so this knife holder class has a different, meron siyang iba't ibang klase ng tilt tilting mechanism. So it can be ibang tilt for forward, ibang tilt for sideways, ibang tilt for backwards. Okay? So nasa nasa sa inyo 'yon if you're using different types of embedding medium. If you're using paraffin embedding medium, medyo nakaslant or slope yung inyong blade. But if you're using celluloidine embedding medium, more uh, uh, less yung angle ng knife. Okay? Okay, next we have the coarse hand wheel. Okay siya. This is located on your left side ng ating rotary microtome. So, coarse hand wheel moves the block holder either towards the knife or away from the knife. So, with this hand wheel glass, ang mechanism nito is nagpapagalaw sa block holder. Okay? Yung inyong paraffin block. So, ano siya? Siya yung nagpapalapit and sa ating block holder. While, okay, next is micron adjustment. Okay? Or the micron meter sa ibang books. Okay? So, this micron meter adjustment. Okay? So, it adjusts or the micron settings for section. So, section thickness can range from 1 to 60 microns on most microtomes. So, this is the micron viewer. So, yung micron adjustment knob nasa likod. Nasa likod siya ng ating rotary microtome. So, dito mo malalaman kung, or dito mo ma-adjust on how thick your sections will be. Okay? So, this usually nasa 0.5 to 1 micra. Okay? 5 to, kasi di ba yung usual is 4 to 6 micra. Okay. Next is the advancement hand wheel. The advancement hand wheel is yung nasa right portion if you're facing the microtome. Turns in one direction and advances the blocks towards the knife at specified microns. Okay. Advancement hand wheel naman class is up and down ng inyong dito, up and down. Okay, if up and down ng blocks. Okay? Kung yung si coarse hand wheel kanina, siya yung nagpapalapit sa ating block holder. Si advancement hand wheel naman class is towards the knife. So meaning up and down yan siya. Okay? Pag malapit na, okay, siya yung usually nagpapadikit sa knife. Nagpapadikit sa blocks and the knife. Okay? So, safety lock. Ito. So, kahit yung ating manual rotary microtome, we still have this safety lock. So, most hand wheels are equipped with a safety lock to prevent the wheel from releasing and having the block holder come down towards the blade while the block is inserted or removed. Okay. So we're not in if not in use class, we are using this safety lock kasi nga medyo madaling mag-move yung ating hand wheels. So probably it can cause damage to our tissues and to our blades if it is not it has moved when not in use. So pwedeng mag-damage yung ating tissue blocks and also our knives. Okay? It should be used anytime the microtomist is not actively sectioning paraffin blocks. Okay? So for safety purposes, itong ating safety lock. Now that's the end for our rotary microtome. Okay? Okay. So we have our last topic. We have staining. For the staining class, I think we have 3 topics for that type of slide. Okay. Okay, staining. So staining, we use different types of dyes. Okay, so dyes are categorized into two. It's either synthetic or natural. Okay, for natural dyes, example, these are obtained from animals and plants. So example, we have hematoxylin, cochineal, cochineal dyes, we have orcine, and we have saffron. Okay, synthetic dyes naman is relatively coal tar dyes. So they're derived from benzene, and collectively known as the aniline dyes. Okay, or aniline dyes. Sorry, both are used uh, as pronunciation for this type of words. Okay, now let's go to our natural dyes. So the very good example for our natural dyes is our hematoxylin. Okay, hematoxylin class is a natural dye derived from the core or the heartwood of a Mexican tree known as the hematoxylin campecyanum. Okay, ito siya. So a powerful nuclear and chromatin staining capacity, and the active coloring agent for her hematoxylin class is hematin. Hematin class is being extracted uh, from its source through ripening. Okay. Ripening is the oxidation process of hematin and accomplished by exposing the substance to air and sunlight. But this is the natural ripening class. Okay, natural ripening exposing the stain or the dye in air and sunlight, but it would take a long time to ripen our stain if it is for the natural ripening lang, exposure to sunlight and air. Medyo matagal siya. What we do now, we have synthetic ripening. Okay, we just add or we add chemicals, okay, to oxidize our stains. Okay, imagine hindi na ginagamit itong natural ripening na ito. Okay, next we have our cochineal dyes. So cochineal dyes are extracted from a female cochineal bug. Okay, uh, usually they lodge on cactuses, thus the name Coccus cacti. Okay, treated with alum to produce the dye name known as carmine. So the carmine is the dye extracted from cochineal bugs. Okay, so we have different types of cochineal dyes. Example is carmine. So carmine is a powerful chromatin and nuclear stain. So addition carmine plus picric acid, we have the picocarmine. Picocarmine are used for neuropathological studies. And then we have the best carmine stain. So it is carmine plus aluminum chloride, okay, used to demonstrate our glycogen, so carbohydrates. Another natural dye we have orstane, okay, is a vegetable dye extracted from certain lichens or lichens, which are normally colorless. So lichens or lichens class are an example or a type of moss, okay? So these orstane glass are used to stain our elastic fibers. Okay, so demonstration of hepatitis B surface antigen and our litmus, okay, is also obtained from lichens or lichens treated with lime and soda and exposed to ammonia and air. So litmus, but we all know litmus as our for our pH, okay? So this litmus paper, yung ating mga litmus papers, okay? So yung stain na ginagamit sa ating litmus or orstane. Okay, now let's go to our synthetic dyes. So synthetic dyes are also known as coal tar dyes. So they are derived from the hydrocarbon benzene and are collectively known as aniline or the aniline dyes. So we have components of our synthetic dyes that helps on exposing the colors of the dye. First, we have the chromophores. So chromophores is the Greek name which means color bearer. So it's a group of benzene ring which confers the color of the dye. So this is the color component of the dye. Okay. Next we have the oxochromes. So from the Greek word which means increasers. So they increase the dyeing properties. So they help the chromophores to expose or to increase their dyeing capacities. Okay, next we have dye modifiers. So these are substances that affects either the color or the properties of a dye. Okay, so lake is the resultant of a complex of stain more than tissue. Okay, a lake class is a component. A lake is a stain plus a component is equivalent to a lake. Okay, lake plus mordant and then the tissue, you will get a lake. Okay, now let's go to chromophore. Okay, chromophores class can be classified into three. We have acidic, we have a basic, and we have the neutral dyes. So acidic dyes class or active coloring substance is found in the acid components and meron siyang inactive base. So example of this is our acid fuchsin. Okay, it's usually a sodium salts of sulfonate or aniline. Okay, another example is our picric acid. So picric acid is usually used as a fixative and is also used as stain. So it differentiate or stain tissue all by itself. Okay, so the basic cell structures examples are collagen. Okay, collagen eosinophilic granules of our leukocytes have an affinity for acid dyes, ions, and these tissues class are collectively known as acidophilic. Okay, those tissues that stains with an acid dyes are collectively known as acidophilic tissues. Okay, so acid loving. Now let's go to our basic dyes. Okay. Basic dyes class are coloring substance found in the basic components that combines with an acid radical. For example, our methylene blue. So basic nuclear stain, which may be used as an indicator and as a dye. So acidic structures, for example, our chromatin, mucous cartilage, and our cartilage matrix have an affinity for our basic dye ions and regarded as basophilic or okay, alkaline loving. Next, we have neutral dye. Okay, neutral dye class are formed by combining aqueous solutions of acid and basic dyes. So these are capable of staining cytoplasms and nucleus. So the very good example for this are our stains used for hematology. Okay, collectively known as our Romanowski dyes. So used in hematology, examples are James's stains, our Irishman's stains for leukocyte differentiation. Okay. Okay, these are the different examples of the Coulter products. Okay, mga synthetic. Okay, okay, so these are the different types of chromophores for the different types of stain. Okay, for the acid fuchsin, we have the quinoid ring. Ito yung chromophores niya. Congo red, we have azo group. Xanthine for eosin. Quinone for imine group or imine group. And oxazine for our cressyl fast violet. And thiazine for our toluidine blue. Next is the oxochrome. So oxochrome are cationic oxochrome for amino group and anionic oxochrome for hydroxyl and carboxyl group. So these oxochrome class are used to intensify our stain. So it helps on the staining process, but they are not the coloring portion or the coloring part of our stain. They just help for intensify the colors. Okay. Next, we have the dye modifiers. So they are attached on the benzene ring. Examples are ethyl, methyl, and sulfonic acid. Now, how do this dye to tissue happens? Okay, so we have different types of dye to tissue mechanism. So tissue will bind dyes by one of those following mechanisms. Okay, first we have the electrostatic mechanism or electrostatic force. So this force class is also known as the combic force. Okay, so it is majority of the tissue dye reaction comprises the majority of tissue and dye reaction. So usually class, example of this is our neutral red and our light cream stains. Okay. Electrostatic force or mechanism class is also known as the Coulombic attraction. So it's also termed as the salt links or electrostatic bonds. So arise from electrostatic attraction of unlike ions. Okay. Example for this, for our basic dyes using electrostatic mechanism is our phosphated DNA and RNA. For acidic, we have the sulfated muco substances. Okay. So for this electrostatic mechanism class, the di-ion binding depends on the charge signs of dye and the tissues, the magnitude, the amount of non-dye electrolyte present in the dye bath, and the ability of the tissue substrate to shrink or swell. Okay. Next is our hydrogen bonding. Hydrogen bonding class, for example, is our Congo red carmine, Uyghur type resorcinol dye. So how do this hydrogen bonding dye to tissue mechanism? So the form of dye tissue attraction arises from the hydrogen atom lies between two electronegative atoms. Okay, so spontaneous thermodynamic changes towards this organization leads to attraction between dye molecules and tissue groups. Okay, for example, we have a staining of the amyloid and cellulose by various biazodyes. Okay. Next, we have the van der Waals forces attraction or mechanism. So example for this is our alum hematoxylin solution. Okay, for van der Waals forces class, it occurs between the reagent and the tissue substrates, involves a various intermolecular attraction. So these forces are polar attractions effective over a short distance. So non-asymmetrical molecules possess stronger dipoles than the symmetrical molecules. So examples for this are staining of our elastic fibers by orsine. Orsine is a large molecule weight dyes, so it has stronger dipoles used in alcoholic solution. Okay, so next is our physical staining. So physical staining, for example, is our Sudan dyes. So sudanophilia is a property of tissues to be stained with or oil-soluble dyes regardless of the type of dye used due to essential lipid nature. Okay. And next is our natural affinity. For example, is our Janus green. Janus green is a popular stain of our nervous system. Okay. Specifically our mitochondria. So they use natural affinity as to dye to tissue mechanism. Okay. Next is method of staining. We have according to the presence of mordant. Okay. According to the presence of mordant class, we have direct and indirect. With direct staining class, it doesn't use mordant. For example, our methylene blue and eosine. The staining process by which sections are stained with a simple aqueous alcoholic solutions of dye. Okay? But when it comes to indirect, kasi di ba, pag sinabing direct staining class, diretso sa stain. But pag sinabing indirect, before ilalagay yung stain, you are going to use mordant. This mordant is a bridge of the tissue to the dye. So it will link our dye to our tissues. So don't forget mordant. Now, according to the presence of differentiator. Differentiator class is also known as our decolorizer. Kaya nga, the other term for the differentiation is decolorization. Okay. So we have three types. We have the progressive, regressive, and counter staining. Progressive staining class, we do not use the colorizer at all. Okay. Example for this is our HNE staining, di ba? Regressive naman, we use the colorizer. So what happens in regressive class? In regressive staining class, we overstain our tissues and then we partially decolorize until we get the optimum color for our tissue. Okay, we overstain the tissue and then use decolorizer for partial decolorization to achieve the optimum color of the tissues. Next is counterstaining. Counterstaining class is application of different color uh, or stain to provide or to prove counterstain or the background provided sa yan. The counterstaining class, we do not stain for the tissue. Yung sinestain natin is our background. Okay? A very good example for this class is staining yung mga capsulated na bacteria, di ba? Hindi kasi na-stain, hindi kasi mahirap kasi silang stain. So we stain our background in order for us to visualize yung mga encapsulated na bacteria. Okay? Counterstaining is also known as negative staining. Okay? Kasi nga ang sinestain natin is not the tissue, not the cells, but the background of the cells. Okay? Next, we have according to the resultant color. I think later on class mag-i-end siya yung ating Zoom, but I will send another link kasi parang less than 1 minute na lang tayo. Okay? Next is orthochromatic staining. Okay? So the color of the dye is same color of the tissue. You can visualize yung color ng dye. If it's blue, then the color of the tissue will be blue. That's orthochromatic staining. Okay? But in metachromatic class, the color of the dye is different on the color of the tissue. For example, the color of the dye is blue, but the tissue appears to be violet or purple. That's metachromatic staining. Okay? Meaning it comprises of different hues or colors sa ating stain. Okay? So the one that is being stained lang and may affinity sa types of that colors, ang masastain lang on that specific type of color. Okay?